we have learned all of the transformation rules that we need. So in the remaining examples for this section, I am going to give you some additional questions that show you alternative ways I can ask you about transformations. Okay, so you might see something like this on a quiz or an exam. These are the types of questions you can expect. Okay, so in example 6, you are given a couple of graphs and it says write an equation for the function shown in each graph. Okay, so let's see. Here's our first function and then we've got another one there. So we are going to have to come up with the formula for the graph that is shown in the picture. And the great thing about an example like this is you can check yourself. If you come up with your equation, you can pop it into the calculator and see if you get the same picture. Okay, if you don't, try something else. Okay, so let's get started here. Okay, so here's the graph in example A, and first thing that should come to your mind is that this looks exactly like one of the basic functions that we saw in section 3.4. This looks like x cubed. Okay, so it has been transformed. Okay, we just have to figure out how and then apply that transformation to the formula. Okay, so what I recommend that you do, okay, if you know your basic function, I would go to your picture and graph the basic function on the picture itself. That way you can compare the original basic function with the transformation, and it may be easier for you to figure out how the graph got moved around. Okay, so x cubed goes through 0, 0. It goes through 1, 1. It goes through 2, 8. Okay, I'm not sure if this is not showing up for you, but there's a vertical line here going through x equals 2. Okay, so let's see. This is 6 right here, so it'll be somewhere up here at 2, 8. All right, and then in this direction, the graph goes through -1, -1, and then -2, -8. So somewhere down here, this is going to be -2, -8. And of course, it's got that same S shape. All right, so there we go. Okay, so this is the original basic function, x cubed, and we're trying to come up with the equation of the red graph. Okay, so let's see. Let's start with the point at the origin, and let's see kind of where it got moved. Okay, it started at the origin, and it looks like it went over 2 places to the right. Okay, let's check the other points. Okay, so if we take the point at 1, 1, it also looks like it went over 2 places. Okay, if we take the point at -1, -1, okay, it looks like it went over to the right by 2 places. Okay, so it looks like we've got x cubed being shifted right 2 units. Okay, let me look at a couple of other points. It's kind of hard to tell with 2, 8 and -2, -8 because they're off the grid, but it makes sense that if we took the point at 2, 8 and we shifted it over 2 places to the right, that it would go over here to 4, 8. Okay, so it does seem like this is correct to take the basic function x cubed and it's just being shifted 2 units to the right. Okay, so we've got to come up with the formula. Okay, so don't think that it's going to be x cubed plus 2. Okay, because remember, if you are adding or subtracting outside of parentheses, that's going to be a vertical shift, either up or down, and that's not what we have here. We're talking horizontal shift because the graph got moved to the right. Okay, so we are going to need parentheses. Okay, what is going to go in the parentheses? Well, the x. Okay, and since we're going to the right, remember the rule is if you go to the right, you have to subtract. Okay, we're subtracting 2 units because that's how many units we shifted right. Okay, so the minus sign is to shift to the right, and then 2 is because we're shifting right 2 units. Don't forget, you need the x cubed somewhere. Okay, so where do you put the cube? Okay, again, if you put it right here, okay, the parentheses don't do anything. You can drop the parentheses. Okay, if you put the cubed right here on the x, that is still a vertical shift, okay, because the parentheses don't do anything at that point, okay? So the proper place, the correct place to put the cube sign is on the outside, okay? So basically when you look at this, okay, you see something cubed, okay, but since on the inside of the parentheses you've got a -2, that's taking that x cubed function and it's moving it to the right 2 units, okay? Again, you can check yourself, okay? If you go to your calculator and you go to y equals, you would open your parentheses, put x -2, close the parentheses, raise that to the third power, okay? You can even go a step further. You can adjust the window, meaning what you see in the x direction and what you see in the y direction. So I'm going to set my x direction to go from -2 to 6, and I'm going to put a tick mark every 1 unit like I see here, okay? So the way you would do that, you would go to window, that's right here, and I'm going to adjust my smallest x value to be -2, my biggest to be +6, and I'm going to put a tick mark every 1 unit. Okay, I'm going to adjust the y-axis in the same way. The lowest y value is -6, the highest is +6, and I'm putting a tick mark every 1 unit. Okay, this way I'm seeing the same exact picture on the paper. So the smallest y value is -6, the biggest is +6, and then we're putting a tick mark every 1 unit. Hit graph, okay, and there we go. Okay, so let's see here if I can kind of, let me see if I can squinch this, okay, so we can kind of compare it to what we've got in the picture here, okay, and it seems like this is the same thing, okay. It looks like we've got, see how on this red dot at 2, 0, okay, there seems to be, you know, that's where that point that was formerly at the origin, that's where it is. Okay, this does look like the shifted graph, so it appears that our equation is correct. Okay, remember if you had mistakenly, if you had originally said that it was x cubed plus 2, okay, it's a really good idea to check yourself, because if you thought that's what it was and you put in x cubed plus 2, okay, you can quickly see that that's not the same graph that you were given, okay? You can see that this is x cubed basically lifted up 2 units, okay? So it is worth your while to check yourself on your calculator, okay? Let's try another one. All right, so for this one, let's see here. Scroll down to part B, okay? First thing you've got to do, okay, what basic function is this? Okay, well, this looks like the square root of x. Okay, it has definitely been moved around. Okay, it's got the shape, but it doesn't lay exactly like the square root of x does. To figure out how it's been transformed, let's plot the original basic function. Okay, square root of x goes through the origin. Okay, it goes through 1, 1, it goes through 4, 2, and it goes through 9, 3. Okay, so this is the square root of x. Okay, so we definitely have the right shape. We just need to figure out how this guy has been moved around. Okay, all right, well, it almost looks like this blue graph has been flipped about the x-axis. Okay, so we are going to do a transformation. We're going to do a reflection about the x-axis. Okay, so let's try that. Okay, so let me write this down, reflection over the x-axis. Let's take the blue graph and actually reflect it about the x-axis and see if it gives us the red graph, okay? So let's start with the point 0, 0. If you take your sheet of paper and you fold it along the x-axis, this point is going to stay, okay? So it's going to stay put, okay? If you take the point at 1, 1, okay, and you fold the sheet of paper along the x-axis, where does it end up? Well, it is currently 1 unit above the x-axis. So when you fold the sheet of paper, it's going to go 1 unit below. Okay, if you take the point at 4, 2 and you fold the sheet of paper along the x-axis, currently this point is 2 units above the x-axis, so it's going to get sent 2 units below to 4, -2. And then lastly, if you take the point at 9, 3, it is currently 3 units above the x-axis. So if you fold the sheet of paper, it's going to go 3 units below. Okay, so it'll end up at 9, negative 3. And this is what the graph will look like after you perform a reflection over the x-axis. Okay, so this is that. Okay, so it's not quite what we want, but we're getting really close. Okay, let's go ahead and write down the equation for this red part, the red part that I drew. Okay, so we had the square root of x. That's our basic function that we started with. And then we reflected it over the x-axis, okay? So if you go back in your rules on reflections, I forget which page this was. Let's try page 7. If you look at your reflection rules, to reflect something about the x-axis, you just need to stick a negative out front, okay? So if you do that here, we're going to put a negative out front, and then that will give us this part, okay? Actually, let me do this. I'm going to color code it for you. Let me put the original function in blue. That's the basic function we started with. Okay, so that's the blue graph. And then if I put that red negative sign out front, that's going to give me the red graph. Okay, we obviously have to do one more thing to get to the graph that was given. Okay, so let's examine it. Okay, so currently we're on this red graph that I drew in. That is negative square root of x. Now we need to take each point, and it looks like to go from the origin to here, I need to lift up 1 unit. Okay, to go from here to here, I lift up 1 unit. To go from here to here, it looks like we're moving up 1 unit. Finally, we're at 9, negative 3. We lift up 1 unit to get to 9, negative 2. Okay, so we take the basic function square root of x, we reflect it over the x-axis, okay, and then we have one more step to do. We need to go up 1 unit, okay? So how does that impact the formula? Okay, well, if you want to go up 1, that's a vertical shift, so you need to add outside of parentheses, which is outside of the square root in this situation, okay? This is the correct equation, okay? And we can check ourselves on the calculator, okay? Let's go to our calculator. We're going to put in the equation that we came up with and see if we get the same graph that was given to us. Okay, so we're going to put negative square root of x. Make sure you get out of the square root because the plus 1 has to be outside of the square root. So it's going to look like this if you plug it in. Okay, let's take a look at the window. The x values go between negative 1 and 10. So let's go change that on the calculator. So I'm going to change my window. The x values are going to go from negative 1 to 10, and there seems to be a tick mark every 1 unit. As far as the y direction is concerned, it looks like we're going from negative 3 to positive 3 with a tick mark every 1 unit. Okay, so we'll put smallest y values, negative 3, the biggest is positive 3, tick mark every 1 unit, and then we will hit y equals, or sorry, we will hit graph to graph. Okay, and now we can compare this to the graph we were given to see if we have a match. Okay, so let me make this a little smaller. Okay, so let's see here. If we compare, okay, it looks like, remember this pinkish graph, maroon, whatever color you want to call it, that's what we were given. It does seem to go through 0, 1, 1, 0. Let's see, let's count 1, 2, 3, 4, 4, negative 1 looks about right. And then if we count all the way, it should go through 9, negative 2. So here's 9, and then that looks about 9, negative 2. Okay, so this seems like the correct graph. It is an excellent, excellent idea to check yourself on the calculator to make sure you came up with a correct equation.